So, okay, now we can go ahead and start. The first topic that we're going to go over is going to be just average versus instantaneous velocity. So, basically, what you need to know for this is um, graphically how you can tell what exactly the difference is um, between the two and how to calculate each one. Um, so, if we just have a graph, we have this simple parabolic function like this. If we took 2 points on this graph, just say these 2 points, and we created a line, this line we could refer to as a secant line. And to get the slope of this, we would just use the formula, y2 minus y1 over x2 minus x1. This is different from if we are looking, so this would be considered be considered an average. And if we're doing instantaneous, if we just looked at a single point on the graph, the line that's tangent to it would have a different slope than the average of these two lines. And to get that, you would want to get a slope. I'll actually give an example of that real quick. So, of average and instantaneous. So, if we had a position function, s of t, and we said that was equal to negative 16t squared plus 4 square root of t, and I asked what the average velocity at from t equals 4 to from t equals 0 to t equals 4 is equal to. The way we would calculate that would be s of 4 minus s of 0 over 4 minus 0. And so if we plugged all this into a calculator, we would just end up getting negative 62 and meters per second. So that would be an example of where you needed to find the average velocity. And if I asked you what's the instantaneous velocity at t equals 4. So if I said at t equals 4, v is equal to, without understanding, that we could just take the derivative of this first off, just the basics of it, what you would want to do is find the slope at points that are close to 4. So like you would want to find the slope from at between points t equals 4 and t equals 4.01, and the between t equals 4 and t equals like 3.99. And so if you calculated the slope, so what you would do basically is s of 4.01 minus s of 4 over 4.01 minus 4. And then similarly here, we would do s of 4 minus s of 3.99 over 4 minus 3.99. And the slope we would get for this would end up being negative 127.2. And the slope we would end up getting for this would be negative 126.8. And since we want the slope at t equals 4, we want the slope of that tangent line, we could simply just average these two slopes. And we will end up getting Negative 127 meters per second. So that's a pretty basic concept, but it's just giving you the difference between if you're looking for the instantaneous velocity at a point t equals something, or if you want the average velocity between two distinct t values. Okay, the next thing, and are there any questions on this before I go on to the next topic? If not, then I'll just move on. Okay, so the second topic is limits. And so you're going to want to um, be able to identify what the limits of uh, identify limits with graphs and with functions. So I'll start off with graphs. I have one example that I want to go through over here. So if they gave you some graph like this with just a bunch of different curves and different functions in here, um, and then they would give you they could give you like a series of different limit examples, and you would have to be able to identify the limit using the graph. So if we went through each one, limit as x approaches -2. So we go to x equals -2. Just because there's not a definite point here doesn't mean that the limit doesn't exist. It does mean that f of -2 doesn't exist, but the limit can still exist because it's approaching a common value. So if we looked at limit x approaches -2, you want to approach it from the left side, and you see that it approaches -1. You want to go from the right side, you also see that it approaches -1. Since those two are the same value, we can say that the limit at x approaches -2 is just -1. And this is the same thing I just, oh, this actually at 2 from the left and 2 from the right. Okay, so if we look at limit as x approaches the value +2 from the left, we see that it's going towards positive infinity. And if we see x approaching 2 from the right side, we see that it goes to negative infinity. Yeah, exactly. So the limit at x approaching 2 is dne because the value from the left and the value from the right aren't equal to each other. Okay, and then just two other examples. So f of 2, there's still a point defined at f of 2, so we can just say that it would be -1. Even though there's no line going through it, there's still a point defined for f of 2. And f of 4, although there you see a curve around it, you have a hole at x equals 4. So can somebody tell me what f of 4 would be equal to in this case? Yeah, undefined. So, and that's basically any type of variation you could see where they give you just some graph, and then they ask you to find the limit at different points and the y value for different x values. Okay. And then I'm going to go over limit laws. So you're going to want to be able to do varying operations with limits. Um, and so uh, as most of you know, that with limits, if we had something like limit x approaches c of f of x plus or minus g of x, that just means that we could split this up and say that we're taking the limit of x and we're adding that to the limit of g of x. So you can split limits like that, and you can also do this for multiplication and division as well. So if I had f of x times g of x, I could just say that's limit x approaches c f of x times limit x approaches c of g of x. And you could do the same thing with division as well. So the operations are pretty simple, but a good example problem for this is if they give you a set of conditions like limit x approaches 2 of f of x is equal to 4, limit x approaches 2 of g of x is equal to 2, and limit as x approaches 2 of h of x is equal to 3. And they could test how well you know how to perform limit operations by giving you a problem like this. So 2 times f of x times h of x all over 3 times g of x. And so based off of our understanding of how limit operations work, we could split this into saying limit as x approaches 2 times f of x multiplied by limit x approaches 2 of h of x divided by the limit as x approaches 2 of 3 times g of x. And we know what all of the limits are equal to. So now we can just plug it in directly. So we know that the limit as x approaches 2, and by the way, these constants that are out in front of the f of x and the g of x, you can move to the front and treat them as a coefficient. So we know that f of x is equal to 4, so we can just say that's 2 times 4. We know that h of x is 3, and we know that g of x is 2. So then we could just simplify this, and that would be 24 over 6, which is just 4. Yeah. And so that would be an example of where they give you different conditions. And you know that you could directly plug it in because each limit is just approaching x equals 2. And so is the question. And then there's, with solving limits, there's 4 different types of methods that you can use. So I'll go over each one. So there's direct substitution, and this is going to be the method that you should try first to see that if you could just solve your limit by plugging in whatever x value you're approaching. So an example where you could just apply this would be limit x, which is 3 x cubed plus e to the 2x plus x over 3. And so if we apply direct substitution to this, we could just get, so we would get 3 cubed, which is 27, plus e to the 6 plus 3 over 3. So we would just get 28 plus e to the 6th. And so this is just a value, and you could apply direct substitution for it. The next method you can use is for if you have a radical. So if you have a radical in your limit, like this example, limit x approaches 9, square root of x minus 3 over x minus 9. So if we go ahead and try to plug in 9 directly, we'll get 0 in our denominator, and then we'll automatically assume that it's DNE. But you can actually rationalize this. So the way to do that is, does anyone want to say what they think or how to rationalize this function? Yeah, exactly. So all we have to do is multiply it by the conjugate. And remember, you're going to have to do this on the top and bottom. Otherwise, it won't be equivalent. You'll be changing the expression. So in this case, the conjugate is the square root of x plus 3 over the square root of x plus 3. And then we can just multiply those two factors. We'll end up getting just x minus 9. In our denominator, we have x minus 9. And we also have this square root of x plus 3. And these problems, remember, something's always going to cancel from top and bottom. So if you don't end up getting that, try restarting the problem because you might have just made some simple mistake. So now we know that these two cancel. And we'll get limit as x approaches 9 of 1 over the square root of x plus 3. And if we plug in 9 from here, we'll get 1 over the square root of 9, which is 3, plus 3, so we'll just get 1 over 6. So that's how you would approach it if you had a radical in your expression. Okay, and then another method would be finding your common denominator. And I'll give an example for this as well. So if we have limit as x approaches 4 for 1 over x minus 1 over 4 divided by x minus 4. Again, if we plug in 4 immediately, we'll get 0 in the denominator. So we have to clean this up a little bit and simplify your expression. And the way to do that is to get common denominator. So in this case, what would be our common denominator to simplify the expression in the numerator? Yeah, so it would be, yeah, 4x. So just the way to do that is I just use this method. So you need to have a 4 and an x as your common denominator. So multiply the opposing terms with whatever they're lacking. So you need a 4 here, you need an x here, and then you have 4x as your common denominator. And you also had x minus 4 in your denominator too, so this kind of just goes right here. You don't need to, it's not, don't get it confused with 1 over x minus 4 and bring it to the top. This just gets divided alongside with the 4x. So now we see that we kind of have common term, but we need to change the 4 minus x to match the x minus 4, so we'll factor out a negative. And we'll end up getting negative x minus 4, 4x, and then x minus 4. Now these two terms cancel. So now we have limit as x approaches 4, negative 1 divided by 4x. If we plug in 4 from here, we'll get negative 1 over 16. Okay, and so I went through this method and this method kind of quickly. Is there any questions on how I solved either of those problems? Okay, if it's all good, then I'll just move on to the last method for simplifying your expressions. And this one's the easiest besides just direct substitution. So an example where you would have to factor, if I had limit x approaches 4 of x squared minus 4x over x squared minus 3x minus 4. Again, if I plug in 4, I get 0 in the denominator. So somebody tell me what I can simplify the numerator and denominator to be to kind of start off this problem. Yeah, so I can make the numerator x minus 4, x times x minus 4, and then I can make the denominator x minus 4, x plus 1. And yeah, x minus 4 and x plus 1. And again, common terms cancel out from the top and bottom. So all we're left with is limit as x approaches 4 of x over x plus 1. This will end up getting 4/5 when we plug in back 4. And those are the 4 main techniques you're going to want to use with whatever type of limit problem they give you. Always start off with direct substitution. If you have a radical, rationalize your expression using conjugate. If you have 2 fractions in the numerator, use the common denominator. And then if you have 2 expressions that you can factor, make sure you factor them after you try direct substitution. Okay, so there's a few more things I want to go over with limits. So actually, I think this is the last thing. So the last thing I want to go over is the precise definition of a limit. And for this, you really need to know how to write it out, like the statement, and then how to solve the follow-up questions they give you for it. So if they give you, just as an example, limit x, and you could think of this kind of as a proof, really. So if they gave you 7x minus 9 equals negative 30, so this is the given information. The statement you have to write out is for every epsilon greater than 0, there exists a delta greater than 0 such that for every x zero is less than the absolute value of x minus the limit less than delta, and f of x minus L is less than epsilon. Okay, and these 2 expressions are really important to include, and also when you're doing the actual math part of this. So in case, if we oh, sorry, yeah, my mistake. This should be right here. This should be thanks for pointing that out. Yeah, this should be x minus a. Okay, x minus a, x minus c, whatever constant. So if we go ahead and apply that for this problem, we'll end up getting 0 is less than x minus, and then in this case your a is going to be negative 3, so x minus and negative 3 is just x plus 3, and that's less than delta. And then if we plug in the f of x minus L portion, we'll get absolute value of 7x minus 9 minus negative 30 is going to be less than epsilon. And this would simplify just to 7x plus 21 is less than epsilon. And then make sure you factor out the absolute value. So you can take out a 7. We're going to be left with the x plus 3, which you want is less than epsilon. And then you can take out the 7 from the absolute value. You're left with an x plus 3. And then go ahead and divide over the 7 so that you just have the x plus 3 left, so that you can get it to match what you have for delta. And now you're going to want to set up a relationship. So this is your after this you're going to need to set up a direct relationship between delta and epsilon. And so in place of this absolute value of x plus 3, I can just go ahead and write that epsilon is delta is less than epsilon over 7. And they could ask you as follow-ups, I think, like what they'll give you different values for epsilon, and then you just have to plug those values in, divide it over 7 to get the corresponding delta value. So are there any questions on how to work with the precise definition of a limit? So, okay, yeah. So when you're doing this last part of the expression, and it wants you to find a corresponding value, yeah, it would be less than or equal to, from what I remember. I don't believe it's directly to, from what I remember, it was delta is less than or equal to the epsilon. Okay, and now I'll go ahead and go to continuity. Okay, let me check the time. Okay, so so there's 3 different conditions for continuity. Do you guys want to go ahead and list them out in the chat? So the first one is f of a has to be defined. And yes, the limit of f of x must exist. And yeah, the limit has to equal f of a. So limit as x approaches a of f of x must exist, and limit as x approaches a of f of x has to be equal to f of a as well for it to be continuous. So those are the 3 conditions. And a common example of a problem with continuity that kind of takes everything into takes all 3 conditions is if it gives you a piecewise function, let's say 2 ax plus b and negative 2. So this is just y equals 2, y equals negative 2, and then y equals ax plus b, and then it tells you what x values those functions are defined for. So we'll say that 2 is defined for x is less than or equal to 1. Ax plus b is from negative 1, less than x, less than 3. And we'll say this is for x is greater than or equal to 3. And your question would be, for what values of a and b would the entire function be continuous? And so there's a way you have to show your work for this type of problem. You need to match up whatever x values between 2 functions. So at negative 1, you need to make sure that the function is continuous between y equals 2 and y equals ax plus b. At x equals 3, you have to make sure that there's continuity between ax plus b and y equals negative 2. So what I do is I just go from, I start off with just one of the x values. So, oh, and also this is negative 1. So we'll start off with x equals -1. So we know that based off of the less than or equal to, that f of -1 is equal to 2. And we know that obviously the limit as x approaches -1 from the left would equal 2 as well. So we need to make sure that ax plus b is, so we need to make sure that basically limit as x approaches -1 from the right of ax plus b is also equal to 2. So that's just the quick setup for that. And then we can go ahead and plug in -1 for x. So we'll get -a plus b is equal to 2. And so this is just our first expression for involving a and b. Over here, if we'll go ahead and use x is equal to 3. And we know that when the greater than or equal to, f of 3 is equal to -2. And we know that the limit as x approaches negative, or the limit as x approaches 3 from the right is going to equal -2 based off of this. So we need to make sure that the limit as x approaches 3 from the left of ax plus b is also equal to -2, so that we could fulfill that third condition of continuity. So once again, I'll go ahead and plug in 3. So 3a plus b is equal to -2. And so these are the two expressions that I'm going to be working with to solve for a and b. So I have 3a plus b equals -2, and I have -a plus b is equal to 2. You can solve it however you want. I'm just going to go ahead and multiply this whole thing by -1. So I'll get 3a plus b equals -2. I'll get a minus b equals -2. Then your b's cancel, then you combine, so you get 4a equals -4, and then a is equal to -1. Then we can go ahead and plug in -1 into this expression, so -3 plus b equals -2, so b is equal to 1. So those are the two values. Those are the values for a and b that you would need to make sure that this entire function is continuous. And just make sure in your actual work that you show that you know what f of each of these x values is supposed to be, and that the limit as x approaches a from the left is equal to the limit as approaches a from the right. Just so you get full credit for those problems. So is there any question on how I approached that problem and solved it? Okay, so then I'll go ahead and talk about IVT. So that's your intermediate value theorem. And so the basics, does anyone want to go ahead and tell me what IVT is? Explain it real quickly. Yeah, so basically if the main condition is if f of x is a continuous function. Yeah, exactly. So if f of x is continuous on interval, just any interval a, b, and f of a is less than 0 is less than f of b, then there exists a point C such that f of c is equal to 0. So if you want to think about it graphically, if I have just any continuous function, and so if it's like something like that, and this is continuous on interval AB, f of a is right here, f of b is right here, there has to be a point f of c that's equal to 0 somewhere in the middle. So I don't really have an example for that. That's pretty straightforward. And then now we'll go over limits at infinity. And I'll go through two examples with this. So if I have limit as x approaches negative infinity of x plus 2 over x squared plus x plus 1, what's the first step I would do to solve this problem? Yeah, so I would take out the highest degree of x from the numerator and denominator. So in this case, the highest power of x is just x. And I could factor in back a 1 plus 2 over x. Over here, the highest power is x squared. So 1 plus 1 over x plus 1 over, plus 1 over x squared. And from here, then you can take out 1x here and 1x here. So limit x approaches negative infinity, 1 plus 2 over x, and then you have 1 plus 1 over x plus 1 over x squared in the denominator. And then you know that as you approach negative infinity for 2 over x, this is going to go to 0, this is going to go to 0, this is going to go to 0. So then you're just left with, oh, and you still have the x over here too. And this is just going to go to negative infinity. So you're left with 1 over negative infinity. And this would just give you 0 as your final limit. And then one more example for this is limit x approaches negative infinity of square root of 4x squared plus 1 over x minus 2. So same thing, I'm going to factor out the greatest power of x, so x squared, and then 4 plus 1 over x squared, and in the denominator I'll have x, 1 minus 2 over x. And now when you have a square root over an x squared, you can pull this out as the absolute value of x. And you're left with 4 plus 1 over x squared x times 1 minus 2 over x. And these two will cancel. You need to know that since this is approaching negative infinity, that this is going to go, you'll have a negative value up front. If this was approaching positive infinity, then this would be a positive x over x. So these two x's cancel now. you're left with a negative sign and 4 plus 1 over x squared and 1 minus 2 over x. And if you go ahead and simplify this, you'll just get negative 2 over 1 because this will go to 0. This will go to 0. And so you'll have the square root of 4, which is 2, the negative sign out front, and then 1 minus 0. So you'll just get negative 2. Okay, and now we'll move on to derivatives. So the first thing I'll go over is the definition of derivative. And does somebody want to write the formula for definition of derivative in the chat? Okay, so not power rule, but it's the first way that you went about solving derivatives using the limit formula. So if you remember, it's limit as, yeah, exactly. So it's limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and this would be just the derivative of the function. If I wanted it at a specific point, then my formula would be limit x approaches a f of x minus f of a over x minus a. Okay, so an example for this would be to find the tangent line, the equation for the tangent line of f of x equals 4 plus x squared at the point 1 comma 5. And so what we're going to use is this formula first to find the derivative. So we'll have limit as h approaches 0. And so for f of x plus h, we'll have 4 plus x plus h squared minus 4 plus x squared all over h. And then we can simplify this so that it's 4 plus x squared plus 2hx plus h squared. Then I'm going to go ahead and distribute this negative into the 4 and x squared, so minus 4 minus x squared all over h. And from this we know that the 4's will cancel, x squareds will cancel, and we'll be left with 2hx and the h squared. So we'll have limit h approaches 0, h squared plus 2hx over h. And then from here, you can factor out the h and be left with h plus 2x divided by h. And these h's cancel. So you're left with limit h approaches 0, h plus 2x. Then you can directly substitute 0 in for h, and you're left with 2x as the function, the equation for your derivative. But the original question is asking you for the tangent line at the point 1 comma 5. So from here, I'm going to need to plug in 1 into 2x to find my slope. So m is equal to 2 times 1, so that's just 2. And then for the equation of my tangent line, I'll have y minus y1, which is 5, is equal to m x minus x1, which is 1. And you can leave it like that, or you can simplify and then move, or like keep the y on the left side and then move everything to the right, but this is sufficient. So if you don't need to show work and it's a question asking you just to find the derivative, then yeah, you don't need to, like as your work, obviously you don't need to do the definition um, of derivative. So you could just use the power rule in a question like that. Yeah, so I mean, I guess in all instances, then you wouldn't really need to use definition of derivative. Unless it was, I guess, what could happen is if they give you a multi-step problem, um, like the ones they have on WebAssign, and you have to like fill in the blanks, and it's like giving you the intermediate steps. So that's the only way they could test you on uh, the limit definition. Um, and then the final thing is just uh, finding the derivatives using the power rule and the quotient rule, product rule. So we'll go over that right now. So, okay, so just the basic expression if I write it. So if I have x to the power of a, and I'm using power rule to get the derivative, I'll just have my exponent act as a coefficient, and I'll have a times x to the power of a minus 1. So power rule is pretty simple. An example problem would be if I have f of x is 4x squared plus 2x cubed plus 3 square root of x. Okay, using power rule, what would my derivative in this problem be? Yeah, 8x plus 6x squared for the first part, and then what about the 3 square root of x? What would that be? Yeah, 3 over 2, exactly. So this could just be rewritten as 3x to the 1/2. So you have 3 over 2 x to the negative 1 over 2, or 3 over 2 square root of x in the denominator. So that would be your final answer for that. That's pretty simple. And then now we can go over two things just real quick for that you just should know. So if I have f of x is e to the 5 cosine of x, what's my derivative for this? Yeah, so it's the first part would be the same, so it would still be e to the 5 cosine of x, but remember using, yeah, exactly. So it would be e to the 5 cosine x times um, negative 5 of sine x, because you need to apply the chain rule for this. So I have e, now I need to take the derivative of this part. So yeah, negative 5 sine of x, and that would be your final answer. So don't forget about chain rule. And make sure you also know that, just to go over it briefly, the derivative of cosine x is negative sine x. And for sine x, the derivative is just positive cosine x. And for e to the x, it's just e to the x. So those are just ones you guys should already know. And next, I'll go over the product and the quotient rule. So instead of just rewriting it, I'm gonna give a straight example. Okay, so how would I find, using product rule, how would I find the derivative of this expression? Yeah, so I'm going to take the derivative of the first part and multiply it by this, and then do the opposite for the next part. So it would be 2x, because I'm taking the derivative of this component, times x plus 5. Then I'm going to add that to x squared minus 1, and then the derivative of this part, which is just 1. So yeah, that's pretty straightforward also. So I'll go ahead and write the general formula now. If I have f of x is u times v, like you guys said, it's f of x u prime times v plus u times v prime. So that's the product rule. And then the quotient rule. An example for this is if I have f of x is equal to 3 minus x squared. Yeah, so if you have even something like the problem, I just make sure you simplify. I didn't simplify just for the sake of time, but yeah, make sure you like go ahead and distribute these 2x and the x plus 5, even with bigger expressions. If it's something that seems unreasonable to simplify, then you can leave it as is, but whatever is easy to simplify, try to do that. Usually, since you're taking it on a WebAssign, I think that I don't think simplifying should be too much of a problem because it can usually accept multiple answers, but just to be safe, if you have time, try to. So for quotient rule, 3 minus x squared over x squared plus 3. Okay, and then somebody tell me how I would solve this one. Yeah, so so you take the lower function and you multiply that by the derivative of the upper function. And then you subtract that from the upper function, multiply that by the derivative of the lower function, and then it's just the lower function multiplied by itself. So yeah, it's just the formula I usually use. I just write it out as yeah, so for quotient rule with something like this, try simplifying um, the numerator again since it's on WebAssign. I'm not sure how strict the grading will be on it. But I remember if I took a test in class, yeah, I would go ahead and try to simplify the numerator as much as possible. You'll probably not get anything that cancels out down here, but you can simplify the numerator at least. You simplify this though, like you don't need to do x squared plus 3 times x squared plus 3. It's fine if you leave it with just x squared plus 3 squared. But yeah, WebAssign, I'm not exactly sure how the grading is. Just try to simplify the numerator if you can. And so yeah, the general formula is just uh, you guys learn it in terms of u and v. I just do, for simplicity, I do low, v high. Low just means the lower function, high is the higher function. Minus high d low over low times low. Okay, and I can give you here, I'll do one more example for product rule just to make sure you guys are comfortable with e and sine and cosine. So if I have e to the 2x cosine of x, what would be what would be my derivative for this? Okay, so could one of you tell me, do you guys also need to know derivative of all the inverse tangent, inverse sine, or do you just need to know? Okay. So you guys need to know tangent, cotangent, all of that too, I'm assuming. Okay, so I can go over that as well. So here, let me just change this problem then. Okay, yeah, that's how you do that problem though. Okay, so then we'll just go quickly through each of the trigs and what their derivatives are. So I'll just say then I'll start from scratch. I'll start from the easiest one. Okay, so what's this one? Yeah. Negative sine x. Okay, those are the easy ones. And then what about secant? Secant is secant x, tangent x, good. And we'll do cosecant 2. Yep, negative cosecant x, cotangent x, that's right. And then we'll do tangent. Yep, secant squared x. Then last one is cotangent x. So what's this one? So it's negative cosecant squared x, right? Just to make sure. Okay. Oh yeah, so this is for all the trigs, and then you guys said you needed to know inverse trig also, so what is the derivative of inverse cosine equal to? Okay, so you guys don't need to know inverse trig then yet. Okay. I was just making sure. Okay, yeah, so you guys just need to know the main trig functions and their derivatives. So that's all of those. And then I'll give one example for something involving like secant and cotangent or something. Okay, so let's see. Let's do cotangent of, no. Okay, cotangent of, just cotangent of x times 3 secant of x squared. Okay, so how would I do this one? And we'll make this cotangent of 2x just because. So we have to use the chain rule for the secant and the cotangent as well. So you don't need to use chain rule first. You need to use chain rule whenever you take the derivative of, well, each component individually. So let's take the derivative of the cotangent 2x first. So remember, the derivative of cotangent is negative cosecant squared 2x, and then applying chain rule, we know that the derivative of 2x is 2. Okay, yeah, so that's the first part, and then we need to take the derivative of the, or we just leave the 3 secant x squared as is, and then we go on to the next part. So we have our cotangent of 2x remaining the same, and now we'll take the derivative of 3 secant x squared. Okay, so chain rule, yeah, I wasn't sure if you guys covered it yet or not. Um, I'll just go over this as the last problem, but I won't do anything else with chain rule after this. Why did you multiply by 2? Okay, yeah, so that is chain rule. So, well, with chain rule, you're going to take the derivative of the outer function first, which is the cotangent of 2x, and we know that the derivative of cotangent is negative cosecant squared, so then we still have our 2x, and then you have to take the derivative of the inner function. The inner function is 2x, and the derivative of 2x is 2, so that's why I multiplied by 2. And then I kept the 3 secant x squared constant, and now I'm leaving the cotangent of 2x constant, and I need to take the derivative of 3 secant x squared. So the derivative of secant, remember, is secant x tangent x, and then you have to take the derivative of the inner function, so times 2x, and then we already had a 3 that I just forgot to include, so 3 is there also. And then yeah, you could say this is like in a problem where um, you could combine these two and then combine these two, but you wouldn't be expected to simplify it any further than that, really. Or I don't even think you could. So something like this, you could just leave like this, and you would honestly be okay for simplifying. Okay, yeah. So if chain rule's not on the exam, then so this problem you can't solve without chain rule. If I made this here, I'll do a different example without having to use chain rule. So what's I'll just make a new problem entirely. So tan x times 3 uh, cosecant x. Okay, so you guys should be able to solve this one without chain rule. So I'll go through this one really quickly. So derivative of tangent x, remember secant squared x. Keep this thing the same. That's our first part. Then our second part, we're going to keep the tangent x the same. And then take the derivative of cosecant, which is negative cosecant x cotangent x times 3. And that would be your answer for that. That doesn't involve chain rule. So that's an example involving trig and product rule. So there's only one more topic I have to cover, and that's just limits of trig. So are there any questions you guys want to go over, or any practice problems you guys want to do with any other topic we've covered so far? It could be anything with limits or quotient product rule or anything we've covered. Squeeze theorem? Okay. Okay, so I'll do one squeeze theorem question and I'll do one. Oh, I'll just do one of each. What have you guys asked? So, and yeah, limits of trig functions I'm about to do after this. Okay, so squeeze theorem. Okay, so 1 second, let me find a good example for squeeze theorem. Squeeze theorem is basically saying if you have, um, oh yeah, so this is a good one. So show that limit t approaches 0 of t squared times sine of 1 over t is equal to 0. And so the way you do squeeze theorem, usually it involves sine and cosine. Um, so sine wheel, what's the range for sine, for a sine function? Yeah, -1 to 1. So basically, if I just looked at this part, I could say that -1 is less than or equal to this sine function, and that's less than or equal to 1. So that's basically my range for sine. And I also know that I have this t squared here in place of being multiplied by the sine t function. So now I could say if I multiply everything by t squared, negative t squared is less than or equal to t squared sine of 1 over t, and that's less than or equal to t squared because I multiplied. My function is not just sine of 1 over t, it's t squared. But I started it off by saying that, okay, I know I have a sine function and I know the range is from -1 to 1, and then I want to multiply back in my t squared, so I can just multiply each component by t squared. So that's just a property of inequalities from algebra. And now I know that since the limit as t, your variable's t, and you're going to take the limit of this and this separately. So I know that the limit of as t approaches 0 of negative t squared is equal to 0. I know that limit as t approaches 0 of positive t squared is also 0. And like you said, it's kind of like meeting at a point. Since I know that the limit of both of these are 0, I can say that therefore limit t approaches 0 of t squared times sine of 1 over t is also 0. So basically, you're going to set up an inequality, and then using whatever variable you're given, you're going to take the limit of that value at the lower end of the inequality, the upper end. Those two values should be equivalent, and that will give you your limit of whatever the middle function is. Okay, so the difference between this and IVT is this is so IVT is just proving that if I have just a continuous function and I have 2 points, basically there's a point in between those 2 points that exists. So that's basically what IVT is saying. This is saying that um, since I know the limit of two, um, this is saying that since I know the limit of like, I'm trying to explain this. So basically you have this really weird complicated function. You know two simpler functions and you know the range. You know what the limit of t squared is going to 0, of negative t squared and positive t squared. So basically you're kind of like squeezing this more complicated function in between these two simpler ones, if that makes sense. Like you know t squared is a simple graph, and you know what it looks like, you know what negative t squared looks like. And this t squared times sine of 1 over t exists in between those two functions. So you're kind of squeezing it to find the limit of the intermediate one. So usually the ones I see with the problems I see with squeeze theorem usually in cosine or sine. And the negative 1 and 1, the negative 1 and positive 1 I got, I started from the beginning because I was trying to define where sine of 1 over t exists. And we know that the lower bound for sine of 1 over t is negative 1, and then the upper bound is 1. Because with the unit circle, the maximum value of sine is +1 or -1. Okay, so I'm going to address the other questions, and I'll come back to squeeze theorem at the end because there seems to be a lot of questions about that. Oh, and the range for tan is so the tan curve is different. The tan curve goes from, I believe, negative pi. I have to relook at, yeah, negative to pi halves. Um, so that would just be the range for tan. So instead of using negative 1 and 1, you would use negative pi halves and pi halves. Wait, let me see. You guys had another question about. Okay, so let me go trig limits real quick, and then I'll come back to the questions that you guys had. This is just the last topic that I want to cover real quick. Okay, so there's two main ones that you need to know. So does anyone know what this equal to? Yeah, so this is equal to 1. And yep, 0. Okay, so those are the two main ones, and then you can manipulate these. They like to manipulate each of these in question formats. So if I had limit x approaches 0 of sine of 2x divided by 5x, does anyone know how I would start this problem? So do you want to multiply by 5 over 5, or do you want to multiply by 2 over 2? Yeah. Yeah, that's what I meant. So like this I could just, because you want the sign of 2x to have a corresponding 2 in the denominator. So what you could do first is just um, rewrite this as sine of 2x over x times 1/5. The same thing as this, I'm just rewriting it so that it looks different. And now what I can do is multiply the top and bottom by 2 over 2. So if I do that now, I can have sine of 2x over 2x times 2 over 5, 2 over 5. So it's the same thing, I'm just rewriting it so that I can have it in a format that looks like this. And we know that sine of x over x just goes to 1, and then a constant times 1 is just 2/5. So that's usually the approach to solving something like that. A more complex example. So do you guys have an example you could type out from like any practice you've done? Because I'm just writing these problems based off of the graded homework I saw. Okay, so combo of tan and sine. Tan x over sine of 5x. So you want to do something like, so something like that. Okay, so let's think this one through. So okay. Okay, well, so we can do one thing to start. So what do you guys think the first step would be to this? Just like the very first step. Yeah, split it up. Split it up. So okay, and then the next thing you guys said was to change tan to sine over cosine. Okay, so if I change tan to sine over cosine, that becomes sine of 6x over cosine of 6x, and I'll have my sine of 2x here also. And over here, I'll have 5x over sine of 2x. Okay. And what can I do from this point? So you're saying to split it like this? Okay, so this is the first part. And then if I take out a 5, so I'll have so right now what we have is sine times 1 over this. Multiply by x over x to get sine 6x over x, and then x over sine of 2x. X over x. Well, wouldn't you need... Okay, so these are two separate limits now. Let's just work with this one for right now. So we have sine this 1 over cosine of 6x. And this just came from when we split it at the beginning. So I just split this into 1 over cosine of 6x times sine of 6x times 1 over sine of 2x. And you guys are saying to multiply this whole thing by x over x. So you'll get so did you split it from here?
I didn't split it at all. I just used it the way it was.
So
So
from this step right here, right?
no, like from the beginning, like the
Oh,
original.
very. Okay.
So what I did was because from after I was doing like the digital homework, I realized that tan x over x is like the same property as the sine.
Mhm.
So then I made it so it's tan 6x over 6x.
Over.
6x.
Okay, so you had to
So
you had to
then like after I divided it by 6x, I multiplied another 6x like right next to it.
Mhm.
And then plus 5x. So I didn't split it at all.
Okay, so then you just did it like 5x, and then all of this divided by sine of 2x?
Yeah, and then I did the same thing for the sine 2x. So I did it sine 2x over 2x times 2x. Because that way I made it a value of 1, but I just
Okay, wait,
I
so this first part, right? Did you have it written as this?
sine 2x. And then I did it over 2x.
Mm-hmm.
And then another times 2x on the side. So then the tan 6x, like the top portion with the tan and the sine x, they just turn to 1.
Oh, okay, so like, there we go, one more. So this portion becomes 1, right? The tan 6x over 6x,
It's the same property as the sine 2x. So it's just 1 times 6x plus 5x.
Hmm.
And then it's over 1 times
1
2x.
times 2x. And then you
And
just
then
have to simplify this to,
11 over 2. Because the x's go away and then
yeah, 11x over,
2.
oh, what there,
It'd be 11x over 2x, and then the x's just cancel out, so it would just be 11 over 2.
oh, yeah, you're right. I never did it like that. I didn't even think about it like that. Thank you.
No problem.
Yeah, so I guess I don't recall ever using tan x over x. But since it's I mean, it did work. Um, I think if you had an in-person exam or you had to show work for it, you would have to use the splitting thing that we were doing at the, like splitting with sine and cosine. Does anyone know a simpler way to do this just using sine and cosine?
So I think that like the method that she just went over, like that makes sense. And like, because what I did was I took tan 6 of x, right? And I just rewrote it as sine 6 of x over cosine 6 of x, right? Because x is approaching 0. That's the same thing as saying sine 6 of x over cosine, or over 1, if that makes sense. Because cosine of 0 is 1. Does that make sense?
Oh, yeah. You're right.
Right,
Oh, yeah. Because when you split up the sine and cosine, cosine would automatically just become 1.
right. And then so then you're just left with sine 6 of x, right? Times 6 of
Mhm,
x plus
Yeah.
5x. Or yeah. And then
Okay, so that's why this would work then. That makes sense. Okay. That makes sense. Yes, 6x plus 5x over 2x. Yeah, that would be the shorter way to do it. Okay, yeah, I completely forgot that since it's going to 0, your cosine x would automatically be approaching 1 from the start. So you don't even need to work that. Okay, don't like that one. Okay, so do you want to go through an example one for definition of derivative, or do you want to like understand the formula? Okay. So yeah, the tan x. That makes sense. Okay, so let's do something like x plus 4. So I need to find the derivative. So I'm going to use the limit definition. So it's a limit as h approaches 0. Your first step is to do f of x plus h minus f of x over h. And then from here, you need to simplify it, because if you plug in 0 for h immediately, you're just going to get 0 in the denominator. Oh yeah, so from here you need to do a common denominator. So you have 1 over x plus h plus 4. You need to multiply this by x plus 4. And you need to multiply this by x plus h plus 4. So now this would become x plus 4 minus x plus h plus 4. And then your common denominator now is x plus 4 times x plus h plus 4. Then you also have your h. Now you can simplify. So x cancels, the 4 cancels. Now you're left with just negative h, x plus 4, and then x plus h plus 4. Now you know these two h's will cancel. Then you just have x plus 4, x plus h plus 4. If I plug in 0 for h, I'll get negative 1, x plus 4, x plus 4, which is just negative 1, and then x plus 4 squared. And then that would be your derivative for the equation. So does that make sense how I worked that one out? Okay. What other questions did you guys have? Okay, so I'll just go ahead and recap some of the things that we went over in the review. Okay, so first thing we went over was just average versus instantaneous velocity. Basically your secant line versus your tangent line. And you will know how to find average velocity if you're given two t values. You need to find the position at s of 4, the position at, or whatever t value, and then the position at the other t value, then just subtract it, so the difference in y over difference in x. And then for at t equals 4, you could use just derivatives if you were trying to understand the concept of it from like, you need to, when we say like h approaches 0, that means you're trying to minimize the distance between 2 points as close to that value as much as possible to find the slope at that point. So at t equals 4, that's why we used t equals 4.01 and then 3.99. These two values are really close to each other, so the difference in them is almost 0. And then you could just average the two slopes. And then with limits, adding, subtracting them, you can just split up the limits individually. Same thing with multiplication and division. With problems where they give you conditions and then they combine them by either multiplying, adding, dividing, whatever, you just split them up first, and then you go ahead and plug in the y values they give you and simplify it. And then for the different limit techniques, the first thing you're going to try is direct substitution by just plugging in the x value that it's approaching. If you end up getting something over 0, you have to see whether you can it's a radical function, so you have to rationalize it. If it's by multiplying by the conjugate, if you can do common denominator, or if you can just factor it out. So it should be one of those three methods. The precise definition of a limit, I think one of you had a question about this. So you basically, I'll run through this problem again. So you know that for a fact that as the limit of, as x approaches -3 for 7x minus 9, it tells you that it equals -30. You have to, it wants you to write up the delta epsilon statement, which is this statement right here. And then you have to set up a relation between delta and epsilon. So we did that here, and these two we set up a relation to because we could just replace the absolute value of x plus 3 with the delta, and that sets up a relationship between delta and epsilon, and then whatever epsilon value they give you, you can just plug it in, find a corresponding delta value. And then with continuity, the three conditions, f of a has to be defined, the limit has to exist as x approaches a. Yeah, so I saw from your graded homework, like the problem she gave you was you had to set up the statement, you had to set up a relation between delta and epsilon, and then like the last part was for different values of epsilon, what's your delta value equal to, if that's what you're talking about. Yeah, so like now that I have the relationship set up, I could say if epsilon's equal to 0.05, what's delta? So you just have to plug in 0.05 for epsilon. So continuity, yeah, f of a has to be defined, the limit has to exist, and then the limit has to equal f of a. And then for a problem like this, just make sure that you take it by each x value, set up the limit, make sure that it's equal to f of a. Same thing for 3. And then IVT, we already went over. Continuous function on the interval. And there's a point where f of c is equal to 0 between a and b. And then limits at infinity. you just factor out the greatest power of x, and you can cancel out common terms from the numerator and denominator, and then see where all of these other values approach. Usually most of them are going to approach 0, and it'll just end up being whatever that you factored out originally. Same thing for this. Definition of derivative, just this basic formula, limit h approaches 0, f of x plus h minus f of x over h. Since you guys are using the sign, you can obviously just use power rule, product rule, whatever. You don't need to use the limit definition unless it asks you specifically to do it step by step. Power rule, take the exponent, move it to the front, subtract the exponent from 1 to get your derivative. We did an example of that. And then product rule, take the derivative of one component and then keep the other component constant, and then add that to the derivative of the other component and then keep one of them, the opposite one, constant. That's pretty simple. Quotient rule, this was the general formula, the bottom function times the derivative of the upper function, then minus the upper function times the derivative of the lower function divided by the lower function squared. And then these are all the trig derivatives we went over. And then squeeze theorem, if you have a function that you can't take the limit of directly, you have to find two other functions that you can compare to, an upper function and a lower function, and squeeze this middle function between those two to figure out what the limit of that function is. So in this case, we know that sine of 1 over t is defined from +1 to -1 to +1. And we're working with t squared, so we have to multiply each component by t squared. We take the limit as t approaches 0 of negative t squared, that gives us 0. The limit as t approaches 0 of positive t squared, that also gives us 0. So that means this middle function also has to be approaching 0. And then limits of trig, the two basic ones you need to know are sine x over x is 1, 1 minus cosine x over x is 0, and obviously I guess now tan x over x is 1, but that's just because the cosine x will automatically approach 1. So, and that's all there is to cover. Are there any other questions you guys have? All right, good luck on your guys' test.